Hey guys, so I was not going to do any further problems with the quotient rule. However, I came across a problem that I think we should go over just in case. So notice that it's asking you to verify the derivative of y with respect to x equals to this given expression here. You once did this in pre-cal verifying trig identities. So we're going to take this one step at a time. So first of all, let's just figure out what the derivative of y with respect to x is first. So we're given the function y. We do have a function of x being divided by another function of x. So we're going to apply the quotient rule. So I don't know why my pen is acting crazy. Sorry about that. F is equal to 1 minus cosine of x. If I take the derivative of that to get it ready for the quotient rule, the derivative of 1 is 0. There's a reason I'm doing this, by the way, minus the derivative of cosine of x is negative sine of x. So if I were to just clean this up, 0 minus negative sine x would be 0 plus sine of x, which is just sine of x. So just make a note of that. And then we have g, which is the function of x it's being divided by, which is just sine of x. This one's a little nicer. So g prime, the derivative of sine, is just cosine of x. So we have it ready to set up for our quotient rule to find the derivative. So the first thing we're going to do, since it says to verify what the derivative of y is first, let's find out what the derivative is itself before we even begin. So dy over dx equals f prime g minus f g prime all over g squared. We're going to substitute the values that we have. So f prime is sine of x, and it's being multiplied to g, which is also sine of x. And then it's being subtracted. We're going to move that out the way a little bit. It's being subtracted to f, which is 1 minus cosine of x, times g prime, which is cosine of x, all over g squared. So g would be sine squared. Since it is just one term, remember that we're putting the square in the middle means the same thing as, sidebar here, as this. So remember, these two mean the same thing. Okay, so cleaning up the numerator is what we're going to focus on. I have, in this case, sine times sine for the first term, which would give me, again, sine squared x. And then, just like the last time, I'm going to move the cosine here, just so I can distribute the cosine properly. So I'm going to find a sidebar so that you can kind of see it. So negative cosine of x, 1 minus cosine of x. I'm going to just move this cosine of x right here so I can distribute it this way. Cosine of x times 1, sorry, negative cosine of x times 1 is negative cosine of x. And then negative cosine of x times negative cosine of x is plus cosine squared, all over the denominator, which I haven't used at all. Now, I'm still simplifying the numerator. Once upon a time, you had Pythagorean reciprocal quotient identities in pre-calculus, and you were told, if you had me as an instructor, to hold on to those identities. And if you look in the numerator, you will see sine squared plus cosine squared, which under the Pythagorean identity tells us that it equals to 1. So we're going to replace that sine squared plus cosine squared with 1 and bring everything else down. Minus cosine of x over sine squared. Okay, well, I've simplified the numerator so that I can't do anything else anymore. However, I need it to equal to this. So what I'm going to do is use my algebra. Everything is already in terms of sine and cosine, which is kind of the ideal situation when simplifying. So I am going to split my numerator, meaning give each one its own denominator of sine squared. I'm going to move this up again. So I have 1 over sine squared minus cosine of x over sine squared. So what I'm going to do is note that everything that I need to verify is in terms of cosecant and cotangent. So I'm going to look at these identities that I keep moving around. So for these identities, 1 over sine squared. Well, if I look at the reciprocal identity, I see that 1 over sine equals cosecant. So if I square each side, and identities, you can modify them just as long as you keep it balanced. That tells me that cosecant squared equals 1 squared over sine squared, which 1 squared is just 1. To square a fraction, you square each one individually. So cosecant squared equals 1 over sine squared. So because of that, I am going to change this first term, that 1 over sine squared, to cosecant squared. Okay, but now what about this? Well, if I look at this term, I have the cosecant squared. I have this one. Now I need to change it to this. If you look, we're going to play a little algebra card here. Meaning, what if I just did this? Is it still true? Well, what if I multiply straight across? Cosine times 1 is still cosine. Sine times sine is still sine squared. So all I did was kind of split up the sine squared. Why would I do that? Well, if you look again at the identities, you'll see that cosine over sine, under your quotient identities, cosine over sine is cotangent. So I'm going to drop down this minus sign that I haven't used, and I'm going to change this cosine over sine to cotangent, and it's being multiplied to 1 over sine, which again, if I go under the reciprocal identities, I know 1 over sine is cosecant, which if I look, it does verify to be what I have here. The plus sign, I have the first term second term first, but it's like 1 plus 2, 2 plus 1, they mean the same thing. And that's pretty much it. So you're using still the quotient rule, but you're stepping it up a little bit by applying the trig identities that you had in pre-calculus. So I hope this helps. I will get rid of this, and I will kind of put a little cheat sheet like I did with the derivatives for the trig identities so that you have that as well. All right, guys, hope this